for lesson 5's homework, we're going to talk about recursively defined sequences again. So for the first part here, they want us to do, is this an arithmetic, a geometric, or neither sequence? So if we remember, our arithmetic are based on adding and subtracting, our geometric are multiplying, and usually our neithers are combinations of the two. So if we look at the first one, a sub n equals a sub n minus 1 plus 2. Because they are told that we are just going to be adding as our pattern, then we are looking at an arithmetic sequence. If we go across to the right, f of n plus 1 equals 4 times f of n minus 1. So they're telling us to do two different things. If they're telling us to multiply and subtract, we're going to be neither. For the third one, f of n equals f of n minus 1 minus 3. The only thing they're telling us to do here is subtract, so therefore it is an arithmetic sequence. And then b of n plus 1 equals 6 times b of n. Well, the only thing they're telling us to do here is multiply, so therefore we are a geometric sequence. Find f of 5 if f of n plus 1 equals 5 times f of n minus 10. Now I know sometimes people don't like the n plus 1 piece. This would be the same exact thing. So if we looked at it this way, they would be exactly the same. So they're telling us our first term is 3. And now we want to find f of 2, f of 3, f of 4, and f of 5. So what does it tell us to do? Multiply 5 times the previous term and then subtract 10. So we're 5 times 3 minus 10. Well, 5 times 3 is 15, minus 10 is 5. So now we'll take that answer and plug it in. So 5 times 5 is 25, minus 10 is going to be 15. So then will be 5 times 15 minus 10. Well, 5 times 15 is 75, minus 10 is 65. So then we will be 5 times 65 minus 10. Well, 5 times 65 is 325, minus 10 is 315. So the fifth term in the sequence is going to be 315. For the explicitly defined sequence, f of n equals 4 times 1/2 to the n minus 1, find f of 4. Explicitly is nice because we can just plug in the 4. So if you're looking for the fourth term in an explicitly defined sequence, then we can just do everything in one shot. We don't have to do f of 1, f of 2, f of 3, f of 4, and so on. So when we do that, 1/2 to the 4 minus 1 gives us 1/8, and 4 times 1/8 is 1/2. So we end up with a fourth term in this sequence of 1/2. If a of 1 equals 1/2 and a sub n equals 1 minus a sub n minus 1, find the first 6 terms. So this is an interesting one because we're going to notice a pattern that starts to develop here throughout this. So our pattern says to do 1 minus the previous term. Well, 1 minus 1/2 is 1/2. So we'll do 1 minus the previous term, which again is 1/2. And what you see is that if you do 1 minus 1/2 over and over again, you just keep getting the same exact answer. So when you have 1 minus 1/2, or 1 minus your previous term, and that first term is going to be 1/2, then you should see that all you keep getting over and over and over again is just that every single term here is equal to 1/2.